Hey, sixth graders, happy Monday. We've almost made it to spring break. Again, I'm sorry I'm not here today, but I want us to go ahead and continue having that growth mindset and growing towards having the best scores possible when we get to our benchmark and when we get to our C Ready scores. So you should have already completed problems 21, 22, 23, 24, and problem 26. Now you're just checking your work for understanding. Even if you got the problems correct, it's best that you do spend a little time going back just for that spiral review and helping your brain remember the activities you've learned in the past. All right. Problem 21 is where we're starting. A teacher asked 3 students to identify how many meters long a fishing rod is that measures 84 centimeters. The table shows the students' responses. So here, student 1 says 8,400 meters. Student 2 says 8.4 meters. Student 3 says 84 hundredths of a meter. So then the question is, which statement is true? And you'll notice they give you a pointer, and they say there are 100 centimeters in 1 meter. There are 100 centimeters in 1 meter. So then we know that from the information, it is 84 centimeters long. So we have to decide now, what do we do with this information? Okay, and the biggest reminder that I can give you here is, I don't know if your teachers have gone through it this way, but this is something I would have taught my students, is we have to know when we are doing a unit conversion, we're changing one unit to another unit, larger or smaller. It helps to remember this saying. Let me see if I can type it out. That probably would make it look better. All right, so let me make this a little bit smaller here. I'm not going to try to spend too much time. Big to small, multiply all. Small to big, I can't put the divide sign in there, divide the pig. Pig is no other reason than it rhymes with big. So I also do a hand motion to help you remember this. Big to small, because your arms are close to each other, they can cross and make the multiplication sign. So big to small, multiply all. But if you go small to big, you can't cross to multiply. Okay, so when we are going from a bigger unit to a smaller unit, we are going to multiply. If we are going from a smaller unit to a bigger unit, we are going to, you've got it, divide. All right, so now we have to look here. If we are going, we want to know how many meters. So we know 84 centimeters, okay? And we want to find out how many meters that is. So we are going from a small unit of measure to a bigger unit of measure. So then think about our saying, small to big, divide. Divide the pig. So what do we know we're going to divide by? Well, I have the number 84, and down below in that square box, they tell us that there are 100 centimeters in 1 meter. So we are going to divide 84 by 100. You can do this with your Desmos, or you can know that when you multiply or divide by units of 10, 100, 1,000, it's just moving the decimal point. Okay, friends, so if I have 84 and I divide by 100, I'm going to move that decimal point 2 places, 1, 2, because we're dividing, to the left. So I end up with the value of 84 hundredths of a meter. So then I come over here and look at my options. Student 1 is correct, student 2 is correct, student 3 correct, or none of them is correct. So I'm going to come over and look. Do I have an option where it's 84 hundredths? A is not, B is not, C is, or student 3. So which one is correct? And that would be student C. It is correct because they do 84 times 1/100th. Okay, or that's the same as ending up saying 84 divided by 100. All right, so there is our answer and explanation to problem 21. All right, moving on to problem 22. Let's click here. Problem 22. What is the greatest common factor, the GCF, of 4 and 10? And if you remember, the best way to find the greatest common factor, this goes back to the beginning of the school year, is to make a large letter F. And you stack the numbers one on top of the other, 4 and 10. And basically, that line reminds you that you're going to list all numbers that can be multiplied to get to that number. So 4 is going to be the biggest number on the top row. 10 is going to be the biggest number on the bottom row. Not multiples. It's not going to get bigger. Factors are the numbers that are smaller that total that number. So what can be multiplied to get to 4? 1 times 4, and I leave space in the middle, and I put a comma. 1 times 4 is 4. And then 2 times 2 is 4. 2 already repeats itself. Those are all the options for factors of 4. The factors of 4 are 1, 2, and 4. All right, let's list the factors of 10. 1 times 10. 2 times anything is 10. Yep, 2 times 5 is 10. Get a comma in there. 3 times anything? Nope. 4 times anything is 10? Nope. 5 times 2, and then you'll see how that loops over itself. So I have listed all the factors of 10. Now, I need to find the greatest common factor. So the factor that is in both lists, that is the largest number. 1 is in both lists, 2 is in both lists, 4 is not, 5 is not, and 10 is not. So now that I know that 1 and 2 are on both lists, which one is the largest? Which one has the greatest value? And that is the 2. So what is our greatest common factor? That is A, the value of 2. Pull out a sheet of paper. You're going to do a you try next, and that is going to be the greatest common factor of 20 and 8. So again, make a large letter F. 20 is going to be the largest number on the top row, and 8 is going to be the largest number on your bottom row. So if we're talking about factors, we know 160 cannot be a factor. If 20 is going to be the largest possible factor, okay, even for one list, 160 is not going to work. Okay, that's simply if you just multiply the two numbers, which is not finding a common factor. All right, so to find the common factor, 1 times what equals 20? And that's 1 times 20. Go up 1, what's 2? 2 times what is 20? Right, 2 times 10 is 20. 3 times anything, 20? Nope. 4 times what is 20? 4 times 5 is 20. Okay, and then 5 times anything? 5 times 4, there's that loop. Okay, so we have all of our factors for 20. Let's do the same thing for 8. 1 times 8, 8 is going to be the biggest factor on our bottom. 2 times anything? 2 times 4 is 8. 3 times anything? No. 4 times 2. Okay, so then we have that loop. We've listed all the factors on the bottom. So now I need to find which factors are common in both lists. 1 is common, 2 is common, 4 is common. 5 is not, 8 is not, 10 is not, 20 is not. So what one is the greatest value? And that is 4. 4. All right, moving on now to question 23, friends. Question 23. Right, next it says write the 7/10 as a fraction. So you have to know the rule for changing decimals to fractions. And decimals to fractions is pretty simple. We are just going to put it over 10, 100, 1,000. Okay, it depends on what place value that 7 is in when it is written as a decimal. So if you look up here at the number, okay, it shows that, that the 7 is in the tenths place, right? If we are talking about place value in the decimals, right? We have the tenths place value, hundredths, thousands, and then it continues on from there. Tenths, hundredths, thousands. So that 7 is here in the tenths place. So what word do you hear? Tenths place. So you put that 7 over the value of 10. there's your fractional form. Okay, the only thing that could be a possible hiccup is if one of the digits or if the numbers could be simplified, then you would have to simplify them to give the correct fractional amount. But in this case, our answer is C, 7/10. Okay, all right. Next we have consider the equations 5 students wrote, okay? And the question then is which student writes a true equation? So which students write a true equation? And when I look at all these equations, I notice right away that they all are going to have a form of the distributive property. And if you remember, a distributive property means to share. And we are going to share equally what's on the outside of the parentheses. Okay, so the parentheses ends up being like a multiplication sign. So if I have 6 times 2, that ends up being 12. And then a plus sign, 12, and then 6 times 5, that is 30. Let's see if the statement is true. 12 plus 30 equals 12 plus 30. Yes, student 1 is a true statement. All right, let's look at 2. We have 4 times 4 is 16. That looks good so far. Plus 4 times 8 is correct, 32. So let's see if our statement rings true again. 16 plus 36 equals 16 plus 32. Nope, not the same on both sides. All right, student 3, 10 times 20 is 200, plus 10 times 30 is 300. All right, let's check our statement. 30 plus 40 equals 200 plus 300. Nope, C is not correct. All right, let's look at student 4. 8 times 3. 8 times 3 is 24 plus 8 times 64. Let me pull out my calculator because this is a calculator section. 8 times 64, and that is 512. 512, let's see if the statement is true. 24 plus 64 equals 24 plus 512. Nope, D is not true. All right, let's look last at student 5. 5 times 5, yep, is 25, plus, what is 5 times 7? And that is 35. All right, let's, fingers crossed this one works. 25 plus 35 equals 25 plus 35. Bingo. There is that correct answer. So really this problem is testing your understanding of distributive property and correctly distributing. So hopefully the repetitiveness of this problem was helpful. All right. To save time, let's go ahead and jump to problem 36. Go ahead and go forward to problem 36. All right, problem 36 says an employee earns $168 in an 8-hour shift. At this rate, how much does the employee earn each or per hour? Okay, we've done a lot of talking here. What does the word per mean in math? And that means one, the one. And so when we see that per or per hour and we see the word rate, we know we are looking for the unit rate. So let's take a look at how we're going to set up this problem. All right, first and foremost, what do we know? We know an employee earns, our ratio is going to be $168. Our comparison is dollars to hours in 8 hours. Make sure you have your labels included. We are writing the ratio in fractional form because it's easy to compare that way. And we are looking for the unit rate. So one of the values of our next comparison has to be the value of what? The value of 1. And it tells us right here, per hour. So where are we going to put 1 hour? On the top or bottom? It goes on the bottom. because hours is already listed here on the bottom, 8 hours, 1 hour. Okay, now we are able to complete our problem to find a equivalent ratio to find that unit rate. And we know that we can scale down here. 8 divided by what is 1? 8 divided by 8 is 1. So I come up here, whatever I do to one part of the ratio, I must do to the other. 168, same thing, divided by 8 equals what? So what is my mathematical problem that I have to complete now? And that is 168, great thing we've been doing all this long division, divided by 8. Think about our steps. Dirty monkeys smell bad. And let's go ahead and go over the steps. 8 can go into 0 or 1, 0 times. 8 can go into 16. How many times can 8 go into 16 without going over? And that is 2 times. Okay, that's the division. Now we multiply on the outside. So 2 times 8. 2 times 8 is 16. 16. Now we subtract. 16 minus 16 is 0. Now we bring down the 8. And then we have to start over again. 8 divided by 8, or 8 can go into 8. You got it, 1 time. 1 times 8 is 8. 8 minus 8 is 0. So, do we have an answer? Yes. And the answer is going to be a money sign, and it's going to be 21. How much does the employee earn per hour? Each hour the employee earns, you've got it, $21. Using and remembering what we have learned about unit rate to solve this problem. All right, so a quick you try. Julio worked 5 hours a day for 7 days at his grandfather's farm. He earned $420. Julio was paid equally for each hour he worked. How much is Julio paid per hour? Well, that's a little tricky, okay? He works 5 hours each day, and he works for 7 days. So first off, we need to figure out how many total hours he works. And we do that by doing 5 times 7. 5 times 7 is, you've got it, 35. So now our ratio is comparing hours worked. 35 hours, I'm just going to put H, and he earns $420. So again, I see how much was he paid per hour. So I'm going to put 1, see that word per, I know I'm going to have 1 hour. Where do I write 1 hour, on the top or the bottom? In this case, I'm going to write it on the top because hours is already on the top. 1 hour. How do I get from 35 to 1 when I scale down? I'm going to do 35 divided by 35. Remember, this is non-calculator, so we have to be able to do some of this arithmetic, some of this multiplying and dividing. Whatever I do to one part of the ratio, I must do to the other part. 420 divided by 35 equals, okay? So again, we have to come over here and do long division. 420 divided by 35. Remember, dirty monkeys smell bad. 35 can go into 4 0 times. 35 can go into 41 1 or 42 1 time. Multiply, that's a 3. 1 times 35 is 35. Subtract. 2 minus 5 I cannot do, so I have to regroup. The 4 becomes a 3. I bring 10 over. 10 plus 2, that makes it 12. 12 minus 5, well, 7, 8, 9, 10, 11, 12. Just double checking there is 7. 3 minus 3 is 0. Bring down the next digit, which is 0. Okay? Now, 70 divided by 35, or 35 can go into 70. I already know this, but you can also think about it as 30 is close, 35 is close to 30. So what's 30 doubled? 30 plus 30 is 60. What's 5 doubled? 10. So what's 60 plus 10? That's 70. So we're going to do 2 times here. 2 times 35 is 70. Subtract. So my answer now is 12. How much does Julio get paid per hour for working on his grandfather's farm. He gets paid $12 an hour. All right, guys, thanks for your hard work. If you have any time left over, please spend it working on a math doku, in classes in HI, somewhere else, or just having a little bit of flex time. Thanks, y'all. Bye.